Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I am your host, Dean Phillips, and I'd like to thank our sponsors right off, localenterprise.com, that's enterprise with a Z, home of the Cody Bot, which is a robot for sanitizing, disinfecting, and temperature measurement for your employees. And with this time of COVID, until we get the vaccination going for everybody, that's going to be imperative. And I'd like to thank the Precision Metal Forming Association and the PMA's Educational Foundation for their continued support of our show. I have with me today Erin Valdez. He comes to us from the Bakery Company, where he is, of course, the Chief Engineering Manager. Welcome, Erin.
Hi, how are you?
I'm doing great, sir. Thank you for being here. So right off the bat.
Thank you for having me.
Oh, it's my pleasure. My pleasure. Tell me, what is your big takeaway that you see coming down the road 5 years from now? What's the big technology improvement or some of the things that you see coming?
I see a lot of remote accessibility coming into facilities and coming into manufacturing through ignition, through VPN, sonic wall, remote desktop, really anything that could be used to access any facility anywhere, so that changes can be made and monitoring can be done on systems, and feedback can be given to manufacturing facilities to help them improve.
Yeah, that's where I think some of the things that we've seen, if you look in terms of the unfortunately, when COVID hit this year, I think a lot of companies had to change to that direction, or as a lot of people like to refer to it now, as pivoting to remote access. Has that been something that was more already in the works for you guys, or something that was, oh, geez, we really need to get this going?
That's something that we've recently introduced. Typically, we did integration and assistance through phone calls or weekend visits when our integrators would come up and help with some issues that we were having. Using remote access and those types of systems, we've been able to do that remotely. So it's not only saved time and money, but it's increased or decreased our downtime relative to whatever issues were being caused, maybe to a processor or something getting out of step in our batching system, or really anything.
Wow. That's great. Did you find that to be more the case with using more vision systems, or just remote access into the control?
More into the control. Okay. For us. Our facility was established in 96. We're still in the process of upgrading a lot of things. We still use some of the same equipment that we had when we started. So integrating new systems into that old machinery has been our biggest take on challenge. And so far we've done well. But, we run across some issues to where just understanding is kind of our downfall of where we're at in the system. Mm-hmm. And when that occurs, then we rely on our integrators to help us and remote in and assist us in stepping through the processes in the processor that are in the programs that help us get back on the right track.
What do you think, looking ahead, how did you get involved in this to get to the point where you are? I mean, obviously, as Chief Engineering Manager, you've seen an awful lot of the issues that are out there and challenges. What was some of the biggest things that led you to this point? I mean, what was your background and what was your interest in this?
My father was an engineer. He was an integrator as well. He still works alongside of me every so often. Just following him, I learned a lot from him, and it inspired me to go and become an engineer. I did an internship at Pillsbury during one of their largest installs that they've had for moving two facilities to Murfreesboro. I learned a lot there. I learned a lot about the logistical side of engineering, and as far as setting up projects and project management, and also learned some of the mechanical while, of course, attending school. It really it helped me in school understand what some of the theory was behind engineering and how to apply it.
Right. I think personally, my opinion is that all the school does is prepare you to learn when you get out there on the job. I think a lot of us really, when you get out there, that's when the learning really starts.
And for me, engineering is about overcoming problems and issues. It's about troubleshooting and being able to be creative and come up with new ways to conquer challenges. And I've always been pretty gifted in being able to overcome challenges and being able to troubleshoot and apply new ideas to fix old problems. And so I think that's really assisted me to get to where I am. And working in my facility, I've learned an awful lot because we do have some newly installed equipment and some older equipment. So being able to bring both mentalities of more of a electrical functional machine to match a mechanically functional machine to make those kind of match up and be able to get a broad spectrum of understanding of older technology versus new technology has really assisted me in my growth.
That's great. Well, I had a question here that had come in before, and I wanted to get your perspective on this, which is they were asking about, are companies seeing more of a quicker obsolescence in equipment? Is the newer stuff coming in not lasting as long or being obsoleted sooner? And whether it's electronic components or hydraulic components, and how are you dealing with those kinds of things?
I believe so. I don't believe it's as rapid as what some would make it out to be. But when your OEMs are continually growing and continually coming up with new technology, because there is new technology for them to be able to develop better technology, it kind of comes with the territory. I mean, for instance, Micrologics is not very old software, and yet here we are growing out of it, going into compact logic and control logic. So I mean, it's one of those things to where it just comes with the territory. Companies have to be ready to face that and to be able to grow with that. I don't see it as much pneumatically as I do electrically with electrical equipment, but I do see it. When they develop better seals and gaskets and better materials, they're going to want to put those into their equipment that they're selling. And when companies are installing this or developing new machines and using their suppliers, I mean, it just kind of comes with the territory is the best way to put it. You got to be willing to grow with modern technology. Sure.
If you look at some of what you've seen in manufacturing out there now with a lot of the IoT things, do you find that you guys are implementing more sensors, more feedback loops in your processes? And how has that helped you?
The Internet of Things, I believe so. I mean, it comes with pretty much any new technology you bring in. We've had equipment that we recently installed in March that was brought in from a company that we just made relationships with. They've been able to assist us remotely with that. We've quoted lighting projects that can sense movement and monitor and send feedback on lighting to let us know our consumption. We deal with IoTs when it comes to really anything, and I think the growth with it is going to be being able to monitor multiple facilities at the same time, catch problems before they occur, get feedback on vibrations or unwanted noise that's coming from a bearing or a gearbox, and being able to use those sensors and monitors to be able to eliminate downtime as much as possible.
No, absolutely. Do you see more of a shift from preventive maintenance to planning and even incorporating some of the artificial intelligence systems and getting to be more predictive?
I do see more of a shift from preventative maintenance to predictive maintenance. The more you can predict maintenance, in downtime, the more often you can avoid it. And this comes with anything from, monitoring viscosity of oils coming from gearboxes, monitoring vibrations in motors and gearboxes, and just overall vibration and noise you can hear in a bearing. I mean, I honestly believe that going forward in the next 5 years, you will see a lot more facilities integrating this type of equipment to kind of eliminate as much downtime as they can. And I see it becoming easier to plan. Not always do you have the ability to plan a gearbox going out in the middle of a day, especially when running. But right. I do believe that when you can monitor it, you can set up in a kind of an efficiency cycle to where you can say, okay, well, this is what we're seeing. We could probably get this much this amount of time out of this gearbox. We can plan it for a week or a month or any equipment, not just a gearbox, but a week or a month down the road. If we don't necessarily have the time now, we should be okay. And you can kind of gauge what your predictive maintenance should be, and it's going to help a lot with scheduling.
Right. Yeah, I've seen, even in our, my daytime job with Link Systems, I could tell you that the element of predicting downtime, and this is more in stamping presses and things like that, but bearing temperatures, if I can monitor it and then I can build a trend based on how long it took. Okay, after there's several different components. First is just time. After running this for this much time and I get to this wear level or this much vibration, I've got typically another 2 months out of it historically. And you build most of this stuff out of history. But then the other element is, what are you running? How hard are you running it? And then it starts to incorporate multiple other avenues of information that starts to have to be combined, where it's not just one thing, it's multiple aspects. And I guess that's where kind of that AI stuff comes in. Do you think that there's more of an avenue or an opportunity there for artificial intelligence to be incorporated into our systems?
Oh, 100%. I believe that, in the future, in very near future, artificial intelligence is going to have a larger footprint in manufacturing and what we're doing out there in our facilities. When you can install or set up software or any type of equipment that can monitor its own system and kind of generate its own homeostasis, in a sense, it can make modifications for you without necessarily having to be in front of it. So say you're getting, too much water or your humidity is too high, and you're making a dough and you're overproofing, those automatic adjustments that can be made without necessarily a human interface is going to only improve efficiency and only improve the amount of manufacturing that we're actually doing on a daily basis.
I think you hit it on the head there, closing the loop of information to action, rather than just, hey, you get a report that this bearing is noisy. You may actually know, okay, go ahead and order that bearing. Or if there's a problem with temperature or viscosity or water levels and balance levels, taking all of that information and being able to act on it rather than waiting for human intervention, being able to act on it and move forward on its own, I think is a great opportunity for people to capitalize on this technology.
And I mean, we see it now. I think it's only going to improve. We see it now to where we're receiving text messages or emails or, automated phone calls whenever there's an issue with something as simple as the sprinklers. So, I mean, having this smart technology and having this IoT, being able to communicate to anyone is it's been not very long now, but it's been a very rapid process, and it's only growing and it's only going to get better. And soon enough, I believe it will be able to have the intelligence to be able to control its own system, and then just send feedback to whomever, just to let them know this is the adjustments that were made and this is the result that we're seeing. And then if it requires human interface at that point, then, of course the human can step in and override and do what it needs to do.
Mm-hmm. Yeah. I think the hardest part when you look at 5 years forward and you think about the destiny of manufacturing is just think 5 years ago, how much we've improved, and then multiply that times at least 2 or 3. And that kind of gives you an idea how fast and how far we'll be going in the near future.
And I believe it's going to be accelerated more than it took for the 5 years for us to get where we currently are. I believe that 5 years will be a 2-year leap in the near future, just as things get better. I mean, to think of how manufacturing was done, 50 to 100 years ago to how we are now is not that long ago. And it's worlds different. It's worlds different.
Right. What other aspects of things like smart manufacturing are you incorporating into your process? Like more robotics? Are you doing more with? Have you ventured into things like additive manufacturing or 3D printing, even from a maintenance standpoint, or any of those kinds of things?
Specifically for my facility, not necessarily. I mean, we do use a lot of extruded plastics. Mm-hmm. We do use a lot of machined plastics, extruded plastics. Just depends on its application. As far as robotics, palletizers, of course, have been introduced, for years now. But just as far as robotics, as far as assembly line, packaging, being able to, put trays in package trays. For us specifically, we've not necessarily gone that direction yet, but I do believe that facilities that do use that are getting a benefit out of it, as far as using robotics, as far as implementing robotic arms, pushers, stackers, palletizers into their system. They're able to increase their efficiency and their output.
You guys used to use quite a bit of air to move your product around as it was getting packaged. Is that still the case, that you're using as much air, or are you using more other processes to move your product around?
Less air now, more actuators and cylinders.
I got
you. We recently did a project for our unstacker, which is what takes the pan out of the stack and puts it on the line to go and receive dough. We used a Macron actuator instead of the cylinder, so we're seeing a more pure and more, I guess, a less violent stroke, a more precise stroke out of the actuator than we were cylinders, which is not only helping with the amount of air that we use, but it's also improving the amount of wear and tear on our pans and our equipment.
Right. And I'm sure that's a technology unto itself of how do we go ahead and make sure that the information that we're trying to make a decision based on is the right one. And, sometimes it isn't always the perfect solution, but it's the solution for the time, and you continue to work forward with that. Do you think that there will come a time where we get to that level of bringing in robots to make our decisions for us?
I hope not, because that would mean less of me out there. But no, I honestly think that we will get to a point to where we work hand in hand with robotics in decision making. I always believe that the human interface is going to be necessary in order to make the ultimate judgment call. When it comes down to any type of manufacturing process, quality is the number one goal. Is the quality of your product that you're putting out and the customer review. And I believe that at this point in time, that robotics doesn't necessarily have the ability to make that judgment call. I believe in the future it may be possible, but I believe it'll be more hand in hand to where we teach the artificial intelligence what is an acceptable variance, and it bases it off of that acceptable variance that the human, that we give it. And if there is any discrepancies, then of course, the human interface would step in. We would step in and make that decision of, is this going to pass or not?
Right.
And using Six Sigma and those are things that you can't necessarily teach, artificial intelligence or robotics to make those momentary judgment calls.
Right.
Just yet, at least.
Yeah. And I think you're absolutely right. There was a study done before where they were trying to develop an artificial intelligence within a robot. And one of the things that we're illustrating was the fact that if the robot's picking up like corks, okay, it's a very small size, very lightweight, and then you introduce something like a pair of pliers, okay, it's longer, it's heavier, and you're asking the robot to figure it out. Well, even a child can figure out the weight difference. Not knowing anything, a baby understands that. Now, that's not to say you couldn't program in a component, but to actually expect a robot to learn it on its own, the difference, the range of motion that it has to move in, to understand the weight differential, to understand how much more force it has to use to lift those. I think that's the component that is still a ways off from developing, but it's getting closer every day in what we're asking robots and machinery to do. I don't know that that's within 5 years. I know a lot of people think that it's closer than we think it is, and it may be. I just don't know if it will be, let's say, commercially available or available to the average person. I think that's always.
I agree that robotics that currently are more job specific. Your point to introducing a pair of pliers to a cork and teaching it to learn the cork and introducing the pair of pliers, and it can't make the momentary judgment call to know the weight and how much force it needs to apply, or even the density of the product to pick it, to be able to make that call. Mm-hmm. I believe it is growing every day. I believe that's going to be the hardest thing to overcome, is being able to visually inspect a product and know what parameters need to be set in order for the robot to do its job. Because that pair of pliers could be made of styrofoam and the robot would not know the difference.
Right. Yeah. And so with your product being in the food industry, what are some of the challenges that perhaps somebody in a different form of manufacturing wouldn't think about that you're faced with?
I would say overcoming older equipment that, now that there's new upgrades and new equipment out there. I would say that overcoming the old understanding of how manufacturing was with older equipment, being able to find the resources to keep that equipment operational. It requires a lot of research. It requires a lot of diligence and hard work in order to be able to find parts that, like we discussed earlier, that are becoming obsolete. OEMs are not only obsolete in their technology, they're obsoleting their mechanicals as well. The drive links, knife links, things like that are becoming harder to find.
Right.
I believe that that's someone in a different field of manufacturing, other than, a bakery or anything, would have a hard time understanding the science behind baking, and what all it takes in order to get a piece of bread out the door, as far as introducing vacuums, encoders, servos, but you may also be working with brake motors and drive, and chain driven. So just my facility specific, it offers a lot of learning with older and new equipment that I feel anybody just walking in, looking at the equipment would have, their hurdles to understand. But in the long run, they would gain a better knowledge of engineering and the mentality that went into designing the machine. to help them improve processes going forward.
Right. How long does it take you if, let's say, from completely being going dark overnight, you weren't running anything, and getting everything up to temperature, getting the right mixture balance that you have to get the first few times through? How long does that take you?
Well, typically we'll go down on a Friday night or Saturday morning. We'll start up Sunday at 6 a.m. We'll do preventative maintenance and sanitation during that downtime.
Mm-hmm.
But from an operator walking in the door and starting to batch, it really depends on our product that we're running.
Okay.
It could be anywhere from 2 to 4 hours. But I would say 2 hours would be the most relative time. That's in order to set up the batching system, set up the recipes, set up the line, get all the numbers and parameters set, put pans through the line, being able to tell whether or not your guides are set, getting the oven up to temp, probably 2 to 4 hours. Typically we try to keep it, hovering
mm-hmm.
at a workable temp for us so that we can, get it to temp faster.
Right.
Because, workable temp for us is 150, 175 degrees. And typically we're baking at 465, 455.
Okay. Yeah. It's interesting because, I've traveled a few of like the manufacturers of materials when you talk about raw materials like steel or some type of composite materials when you get into some more advanced, and you have blending of different materials that you're trying to do, and you're trying to get it at a temperature. Getting that balance right, I'm sure is probably at least as complicated as it is for you guys to try and get the balance right when it comes to cooking, because it just isn't quite at that level temperature-wise and things like that. You have to get the balance of water that you're doing in. Is that all computerized for you guys now, or is that still something that requires a lot of intervention from some of your quality control people?
It requires a number of interventions. Our operators are trained to be able to see the line and know what adjustments need to be made. Quality as well. Our QA department is very involved. And each dough that goes out the door, they're checking everything from the proof or humidity to the oven temperature to the color of the bun to the way the bun is, if it has a split or if it needs water introduced. We have, a couple systems in line that help that process as we move along, so that we can kind of correct it before fixing the dough. We use the introduction of a mist tunnel. Our mist tunnel introduces water to help with splitting. We can make adjustments to humidity and bake time to help dough get out of the pan if we're seeing darker heels and we can speed up our lines to make sure that we're not necessarily adjusting the temperature, but we're decreasing the bake time by speeding up the line to where we're not getting too dark a product. Every flour that comes in through our hoppers has a variance to it. I mean, it may have it may be a little bit wetter, it may be a little bit different, maybe a green flour. It's really dependent on the individual dough and what type of flour that comes out.
Right.
And those adjustments, like I said, are made on the fly, and our operators do a phenomenal job of being able to make those judgments and those adjustments.
Yeah. So in other words, you can't just, if you want to double your production, you can't just crank it to 800 degrees and just whip it through faster, huh?
No, there's a little more science behind it, a little more use of STEM there.
Well, that's great. So tell me some of the other challenges that you're faced with, or things that you're looking forward to over the next 5 years that are going to help prove solutions for you.
I would say in the next 5 years, for me in my facility, our biggest challenge is going to be keeping up with technology, keeping up with the growth. Mm-hmm. It changes every day. It changes very rapidly. So being able to get these new upgrades for our machinery, being able to get, new machines in, floor spacing and layout to be able to, integrate and use in, I guess, bring these bigger, larger machines in. Just because technology is up to date now doesn't mean that the machine is any smaller. Typically, in what I've seen, they tend to get bigger.
Right.
So just bringing in these larger, heavier machines to do the same, to do the job is going to be a challenge for us. Being able to keep up with the amount of changes that occur with new technologies, and like I said, just as we face now, finding obsolete objects as they become obsolete.
Yeah.
Whether it be processors or cards, or whether it be cylinders or anything, and then modifying our equipment to being able to keep up. Whether it be simple as modifying a bracket or modifying a conveyor to necessarily modifying a basket stacker to pick up a different style of basket, or just it really comes with progression. And technology will be our biggest challenge and anybody's biggest challenge as far as keeping up.
Great. Well, Erin, thank you so much for coming on today. We're just about out of time, and I really want to thank you for being here. Thank you for taking time out of your busy schedule. Erin Valdez from the Bakery Company, thank you so much for being here. I want to thank our sponsors, localenterprise.com. That's enterprise with a Z. And we would like to thank them and the Precision Metal Forming Association.